All right, hi everyone, and welcome, and thanks for joining us for the No BS approach to Arc Flash. I'm your host today for the webinar, Matt Tonkin. With me today, I have, or actually, I should cover a few housekeeping items before we get going. We do have a question and answer period, which we're going to be doing at the end of the webinar. So if you do have questions in the meantime, if anything pops into your mind while you're going, there is a box that you can enter questions into. They'll come over to us and we will try to do our best to answer them at the end. If there's something we don't know, we're not going to try to give you information that we're not sure about. So what we'll do is take those questions and going forward, we'll look into the answers and try to get those to you. So with me today, sort of being the panelists for today, are Robert and Matt. Robert is our VP of US Sales. He's worked in the safety industry for over 40 years. Matt is our content marketer. If you've been on our blog, if you've seen any videos, anything like that, you've probably seen a bit of Matt's work. He spends a lot of time doing research on the articles he's writing to know about different aspects of safety industry.
Thanks for having us.
So why do we want to cover Arc Flash? There's about 2,000 people treated annually in burn centers because of Arc Flash industries, and 2 out of 3 of those electrical injuries are because of worker error. So what we're trying to do here with the no BS approach to Arc Flash is not to cover so much the technical stuff that's a little complicated to get into, but we really are trying to raise awareness and put it in a form that's easy to understand for everyone, and something that everyone can get a bit of information out, even if you don't know exactly all the technical part. So with that, I'm going to pass it on to Matt and Robert, and they will take you through everything.
Very good. Thanks very much, Matt. So my name's Matt Brittany, and I guess a great spot to start is with discussing what an arc flash actually is. So basically, it's an electrical explosion, and it happens on energized equipment. So it could be an air conditioner or a conveyor belt, for instance. Basically, you have these electrons that are moving back and forth across a conductor. So a conductor is anything like a wire. A small area outside of that wire is going to be energized. And if the equipment that's energized, the piece you're working on, voltage can push those electrons off the conductive surface and onto atoms and molecules in the air. These atoms, when they're energized, become ions. So if another conductor gets inside the energized area, wrench, moisture in the air, dust buildup, or a worker's hand, the electron travels through the new path, and as the electrons push themselves off between the 2 conductors, that's when your arc occurs. So it's a huge flash of energy. I'll pass this over to you now, Robert.
Thank you, Matt. You know, most people don't think about it, but a good everyday example of an arc flash is the flipping of the switch in your house and turning on a light bulb. The inside heating of the element and all basically creates a very minor, mild arc flash in that process. An arc flash in the industrial world can actually reach up to temperatures of over 35,000 degrees Fahrenheit, which is approaching over 4 times the heat of the sun. And depending on the voltage of the machines and where the workers are and things like that, there are still dangers for up to 2nd-degree burns by as far as 20 to 30 feet away from the machinery that you might be working on. So always keep in mind what your voltage is on the piece of equipment that you're working on. Matt?
Yeah. So what causes an arc flash? Unfortunately, most of arc flashes are caused by human error. So our presenter, Matt Tonkin, gave the statistic at the beginning: 2 out of 3 electrical injuries are a result of worker error. So it's things like working on energized equipment, it's not properly using lockout and tag out devices, it's a lack of upkeep to machinery. It can also be when you're working on de-energized equipment, but you leave like a wrench or a tool in the area. Once that machine is re-energized, those types of things can cause your arc flashes to occur. So I'll pass this back to you, Robert.
All righty. How to prevent an arc flash? Probably the only foolproof way of doing this is making sure that your machine or piece of equipment is de-energized, i.e. that there's no power whatsoever coming to it. This way, there's just absolutely no way an arc flash can happen. But in the real world, that doesn't always happen. So your general maintenance will be is to use a proper lockout tag out program. There are certainly guided procedures and many ways of doing this that meet the OSHA regulations. One of the other pieces would be is that you're following your proper lockout and tag out is to double check and take a voltage reading once you're in the machine or in the part of the machine that you might be working in, and make sure that you have properly locked everything out and de-energized the piece of equipment that you're working on. Matt?
All right, and so from here we should talk a little bit about calculating your risk of arc flash. Different areas where you are from a piece of machinery, you're going to have a different risk factor. So in some cases you do have to work on energized equipment. So the National Fire Protection Association, they developed a specific approach boundary designed to protect employees. So in the next slide, we will look at those different approach boundaries. So this is the area called the flash boundary approach, or the outer boundary. And in this area, this is the farthest boundary from your energy source. And basically, if an arc flash does occur, this is the boundary where an employee will be unaffected. So they won't be harmed from any of the, if an arc flash does occur. And then we have our limited approach boundary. This is the minimum distance where an unqualified personnel may safely stand. So someone like myself, who has no formal training in arc flash, that's the closest I could be to our energized equipment. No untrained person can approach any closer than this boundary, and the qualified people who are allowed to go past there have to have the appropriate PPE. They have to be trained to perform the required work, and they have to have a reason to actually go across this boundary. From there, we have our limited approach, restricted approach, right here, and this can only be crossed by a qualified person. So it requires techniques and equipments, and training must be completed as well. And this is kind of where your shock hazards become a little bit more of a possibility is in this area. And then finally, we have the prohibited approach boundary. So to get into this area, a lot more requirements need to be met. So it requires the same amount of protection as the worker were to make direct contact with the machine itself. Only qualified personnel are permitted to be in this area, and they need to have the following things. They need to have the appropriate PPE. They need to have specified training on the work for energized equipment. They need to have a documented plan justifying the need to perform work on energized equipment. Anyone in that area must obtain a risk assessment to cross the prohibited boundary. And this boundary is determined by NFPA, which is the National Fire Protection Association, their standard NFPA 70E, and it's based on the voltage of the equipment. Now, these distances aren't going to be consistent between every piece of equipment. So some equipment will have a greater flash protection boundary, while other equipment will have less of a protection boundary. So it really depends on the voltage that you're working with. And so Robert will talk a little bit to us about selecting the appropriate PPE.
Thank you, Matt. The best place that we can recommend everybody to go, obviously, is to the NFPA 70E standard. The websites are just full of good resources to find charts and posters and pieces of different types of PPE to wear. Today, we're only concerned with your hands. And at this point, I just want to make real clear that we are dealing with arc flash protection only. The gloves and things that we're talking about today will not prevent electrical shock. That is a totally different set of gloves and PPE requirement for doing that. So if you don't take anything away but that, remember that an arc flash glove is never going to prevent against a shock. The reverse of that would be that if you are wearing rubber insulated gloves and the leather protectors to protect against shock, you can also be protecting against arc flash at that point, but not in the reverse. So when you're choosing your arc rated gloves, some of the things you need to look at are the arc thermal performance value, or what everybody generally refers to just as the ATPV. This is the incident energy needed to cause a second-degree burn. It might sound a little confusing, but if you wanted to look at it and think about what is 1 cal, think about taking your finger and sticking it to the top end of a Bic lighter that's lit and leaving it there for 1 second. That's a very generic example of what 1 cal would be like. So when you tell that somebody's doing that for an 8 cal or a 20 cal or 40 cal, it's obviously going to be much, much hotter than that. So the incident energy is generally measured at a distance in testing of up to from 18 inches from the actual arc flash itself. It's called the incident energy because it's energy that isn't supposed to be released. It should be contained. Basically, your ATPV on a piece of PPE means that you have a 50% chance of enough heat will transfer through the PPE to cause the onset of a second-degree burn. So just put that in good plain English is when you're wearing an arc flash glove, the protection factor that you're basically getting that says you've got a 50% chance of walking away. In our example, we're going to say if the glove is an 8 cal rated glove, that up to 8 cals, you've got a 50% chance of walking away without getting a second-degree burn. So none of this protection is 100% foolproof. Matt?
Yeah. And so Robert kind of touched on that one, but it might help to remind everyone what 1 calorie would be. So hold your finger over a Bic lighter for 1 second. That's 1 calorie of heat. And it can take as little as 1.2 calories per centimeter squared. So just slightly more heat for the onset of a second-degree burn. So when we say second-degree burn, we basically mean, you have red, blistered, swollen skin. You might be needing to use salve on it at that point. It's going to feel pretty tender. So what we'll do is, this was a glove. This is our S18 KGNE, and we released this in January of this year. And I'll have Robert talk a little bit about what makes this glove so special for arc flash.
Thank you, Matt. One of the biggest advantages of the S18 KGNE is the dexterity that you get. The glove is a based 18 gauge knit glove, which is one of the thinnest knit gloves used in PPE today. Our particular glove is used with a base of Kevlar. We also have a liner inside the glove for the back part of the hand. The glove gives you a ANSI cut level rating of A3 according to the new standards, with an arc flash level 2 rating, and this carries a 8.2 cal rating with it as well. So the dexterity has been the biggest issue in my dealings with maintenance people and all, that they put them in the bigger, heavier voltage gloves, and even with a leather protector, they find that they can't do their job. This particular glove now addresses that purely from an arc flash standpoint. Remember, we're not going to be giving you any electrical shock protection with this. The glove is also flame resistant tested according to the ASTM F2675 standard, which, understanding that standard, you test the lowest protection of the glove. In this case, that would be the back of the hand. By adding the palm dip to a glove like this, you can actually increase your cal ratings on these up to as high as 50. So having a palm dip glove with the proper palm dip on it, in which case we use a high temp neoprene palm dip on ours, you're actually increasing your protection for the glove at that point. Matt?
Yeah, and I'm glad that you bring up that neoprene palm coating. So basically, when a glove is tested for arc flash, it's tested based on the least protective area. So that's usually going to be like the back of the hand. So for the S18 KGNE, it was rated at an ATP value of 8.2 calories per centimeter squared. But the neoprene palm coating can get somewhere up to about 50 calories per centimeter squared of protection. So your palm coatings are really good news for the arc flash industry, or industries that are facing the hazard of arc flash, because your palm and your fingertips in the event of an arc flash are going to be some of the areas that are going to be most affected by the arc flash. So it's really good to have that little bit of extra protection where you need it the most. And what we're going to do next is show a clip of that S18 KGNE in the DuPont Thermoman demonstration. Can arc flash be used for shock? Robert, you kind of mentioned that one already, but I think it's a really important thing to repeat. So, can it be used for shock?
Thank you, Matt. And I'll agree with that. That's probably the biggest question and confusion that I find out in the marketplace, is that people do confuse the arc flash with an actual electrical shock resistant glove or shock prevention glove. So even a low voltage electrical glove with a leather protector on it is going to give you a combined arc rating. But again, as we mentioned earlier, you're talking about gloves that are much thicker and obviously make it very difficult for a maintenance person to do their work on a machine when they have to. So just always remember that the arc flash product is not going to give you any type of electrical protection at all. And the other thing to, I think, mention here is that most people have had the understanding that if you were below 240 volts of electricity, you didn't have to really worry about it. But the actual standard now states that anything at 50 volts or more should be treated and tested as though arc flash was certainly a possibility, because it can happen at lower levels than 240 volts. The evaluation and the actual boundaries that will perform, that your employee might be performing, will obviously dictate the level of glove and protection that you might want to look at, because there are arc flash gloves, probably level 2s all the way up to the level 4s that you're talking about, gloves now that are up in the 40 plus cal rating range. Matt?
Perfect. Thanks very much, Robert. And so I guess now we'll start moving on to our question and answer section, but I'll pass it over to Matt Tonkin here.
Yeah, and I already see a lot of questions coming in, but again, we find in the webinars that these are really the most important part to get some of the questions out there. So start out, can an arc flash still happen if there's no exposure to Energizer conductors? This is a question that's come in a few different sort of ways it's been written. Some people have asked if there's risk for arc flash where there's no risk for electrical shock, and vice versa.
Yeah, so in terms of can an arc flash still happen if you have exposed energized conductors? Yes, it can. So things like inserting or removing draw-out circuit breakers, bus plugs, MCC buckets, anything like that, it can cause an arc flash where there normally wouldn't be a perceived hazard. And so that's one of those things, which is why OSHA requires workers to de-energize equipment whenever possible when they're working on or near it.
Another question we've had is about laundering and the effect on particularly the gloves, but I guess PP in general, what effect that could have with an arc flash. Robert?
Yeah, I'll be happy to deal with that. Yes, these gloves can be laundered. And one important thing to remember about your PPE equipment when you're around arc flash is you shouldn't be using the equipment over and over and over and using soiled equipment, because as you work on different machinery or pieces within your plant, chances are you're going to get grease and other maybe cleaning fluids on it, that these are flammable. So you're now increasing your possible risk of a severe burn if you don't launder the product. And typical laundering of arc flash materials, seeing how most of them, to my knowledge, are made of an aramid fiber like Kevlar, you want to make sure that you don't put any bleach in with it, as this can actually harm the PPE base material itself. And wash and dry these at low temperatures, generally in the range of at least 150 degrees Fahrenheit or less, and using mild household detergents is all that's needed.
Great. Another common question that I'm seeing here, most people are asking about their own specific jurisdiction, but I'd say let's try to cover as many as possible. What standards are being used when you're evaluating a arc flash rated glove?
So OSHA works with the National Fire Protection Association, and they created NFPA 70E, which is kind of the standard for regulations and for personal protective equipment. The standard that was developed by the Institute of Electrical and Electronic Engineers, which is the IEEE 1584, is to provide the method for calculating the incident energy of an arc flash event. So hopefully those help you. So if you are looking for PPE, the best standard to look for, the one that the most common one, is the NFPA 70E.
One other thing I'll add there, Matt, I was at a show earlier this week, and a gentleman asked a question very similar to that, is for those of you who were able to see the video that we showed, that was not an arc flash. That was nothing more than the thermal burn of material that happened to be performed by DuPont in their, I think they call it their Thermoman test. It's about the equivalent of a 2-cal arc flash, but it was not meant to be viewed or looked at as an arc flash in itself. So it's important to remember the difference between those two and make sure that your product is actually arc flash tested. It should have the arc flash symbol, which is the triangle with what I'll call a little explosion-looking diagram in the middle of it, and give you a rating out to the side.
Great. And sort of along that same vein, what is the minimum arc flash rating for PPP for a category?
Yeah, for sure. So category 0, which is considered the type of PPE you need to wear for that, is not really a category for arc flash, but it would be your 1.2 calories per centimeter squared, and you'd have to wear at least an untreated cotton for that. So that's the minimum calories per centimeter squared for the onset of a second degree burn. But basically, under NFPA 70E, the 2015 edition, there are 4 categories. So category 1 would be a minimum arc rating of 4 calories per centimeter squared. Level 2 would be 8 calories per centimeter squared. Level 3 would be 25 calories per centimeter squared as your minimum PPE rating. And category 4 would be 40 calories per centimeter squared. And again, you can find all of those in the NFPA 70E standard. But each layer of clothing under arc rated clothing reduces the heat received to the body by about 50%. So when you add an FR layer under your arc flash clothing, it doesn't increase the arc rating, but it just reduces the amount of heat that's being transferred to your body. And Robert, maybe you can comment a little bit on the specific gloves that we offer that kind of meet in each one of those rating categories.
I'll be glad to. Obviously, the glove that we showed in today's presentation, the S18 KGNE, this is the thinnest flash glove carrying a cut level 3. It has a high temp neoprene palm dip on it. It gives you a 8.2 cal rating, which would give you the level 2 rating. We also then have a second knit neoprene palm dip glove that carries an ANSI cut level of 4, the A4 under the new standard, and it too is also a level 2 rated glove at a 9.2 cal. And when I say cal, it is all cal per centimeter square, just so I don't want to confuse anybody. From that, we go into our goatskin driver style gloves with Kevlar liners inside of it. Both are ANSI cut level A4 rated, and one carries a arc flash rating of 3. This is a standard goatskin glove with the Kevlar composite liner in it. And our Endura with oil block carries a arc flash rating of 4, which exceeds 40 cal rating. The advantage to this glove is that the glove is specially tanned so that oils and greases won't penetrate through the glove. And as we mentioned earlier, it's very important that once you use a piece of PPE around a piece of machinery, if you get it soiled, please launder it before you use it again. Otherwise, you could be leaving materials on your PPE that can just increase your chances of a terrible accident happening.
Another common thread question that I'm seeing is concern about both risk of arc flash and electric shock. The question being along the lines of what are the steps that someone can take if they do have risk for both of that?
Well, if you're going to have a risk where you've got the potential for arc flash, you're having to obviously work on an energized piece of equipment as well as electrical shock. With that, now you're going to have to be wearing an approved voltage-rated rubber glove, as I'll use that as a generic term. And most of these generally will also be in conjunction with a leather outer glove to help protect the rubber glove so that you don't accidentally poke a needle, fine needle hole or a pinhole in it, in which case the electricity would just find its way through it. So it requires a glove that is rated for electrical shock, and these come in a multitude of levels from low voltage all the way up to extreme high voltage.
Another question that I see here is specifically about our gloves and whether they can be used in the prohibited approach boundary that we mentioned earlier.
Yes.
Robert, could you maybe speak to that one?
Gloves that we have can be used in those areas. It's not something, when you get into that area, you are really in an extreme danger zone. But let's throw an example out of saying that you're going up to throw a breaker switch or pull a main switch on a box. In that case, you're going to be standing within that zone, and having that glove on versus not having that glove on can mean, as we said earlier, you've got a 50% chance, depending on the voltage and the cal rating of an arc flash at that time, as to whether you walk away without a severe second-degree burn or worse, or hopefully we keep the burn and the incident down to that level. So wearing something like that at that point is certainly better than not having anything on at all.
Another question we have here is whether your typical home electrical panel is going to be at risk for an arc flash.
Yeah, so basically what OSHA, the regulations, what they mandate is that any equipment operating over 50 volts or higher needs to be tested for the arc flash hazard. So if you have something that's over 50, it used to be, the misconception was that if it was under 240 volts, an arc flash wasn't possible, but it's not the case. So any equipment you're operating over 50 volts, chances are it needs to be tested for arc flash. It's a lot harder in those low voltage areas for an arc flash to be sustained, but over 50 volts, it needs to be tested.
And what's going to cause an arc flash to stop?
Yeah, absolutely. So on an industrial scale, there's large switches or circuit breakers that are designed and they're in place to flip quickly. So your arc flash won't really be a sustained explosion. It'll be fairly quick, but the area between the two surfaces will quickly separate and the arc dies off because of those switches and circuit breakers. Most energized machinery is made with arcing contacts. They're going to capture the arcs and direct the arc into specially insulated containers so it can't cause any more trouble. And in some cases, your medium or your high voltage circuit breakers, they'll actually have vacuum tubes or special gases which are designed to extinguish or suppress the arcs.
Is there sort of a catch-all distance that you should be using when trying to avoid arc flash? Is there a specific distance? How is that going to work?
Yeah, so unfortunately, it's not as easy as 10 feet away, you're always going to be safe. Depending on the machine, depending on the voltage that you're working with in that machine, that's going to play a big part in how far you need to be away from the machinery. But again, that standard, the EII 1584 will be able to help you calculate your boundaries.
Another question, and this relates back to, again, with rubber insulated gloves. Should you be wearing your arc flash gloves over those or under the rubber gloves?
Well, I can tell you from just my years of experience in doing it, it's that I've never seen anybody wear an arc flash glove in conjunction with an electrical shock glove, because if you're worried about shock and preventing an electrical shock, like I said, you're going to be wearing it can be a low voltage or a high voltage rubber insulating glove, and generally these are worn with a leather protector over them, and thus the need for the arc flash in conjunction with that is not needed as a rule. Now, I'll be the first to tell you, I am not an electrician, and that might be something better suited for a little more in-depth research, but this is the answers that I've gotten back from dealing with many of the electrical companies throughout the United States over the years.
And Robert, one question we have here is, if you don't have someone like an electrical engineer on staff who can help you out with this, how is an employer going to be able to determine what level of PPE they should be using?
As it relates to an arc flash, if you don't have an qualified electrician or electrical engineer on site, my first suggestion would be is don't mess with it. Call a professional. We hear that on television ads and things all the time, and it really does mean a lot. I would say that hopefully any industrial environment should have a lockout tag out procedure in place, and please follow that to its nth degree, so that if you totally de-energize the piece of equipment, and we make sure there's no capacitors or anything in there that might be storing energy, then you shouldn't have a problem with an arc flash. But again, if you don't have somebody that's educated about electricity, you're better off to just don't mess with it and let a true electrician or certified electrical engineer handle that situation.
So we've talked mostly about gloves so far, but there have been a couple questions. Do you have any suggestions about arc flash protective sleeves, for instance, or suits as well that can protect against them?
Yes, there are companies out there that specialize in making this type of equipment. They'll make they have hoods, and if you go to the NFPA 70E, just type that in on the website and look, you'll find all sort of articles showing different types of clothing that can be worn. As Matt mentioned earlier, depending on what level you're at as far as the ratings and the cal ratings, it can be as simple, if you're down at a very low cal rating of 4 or less, simply just wearing 100% cotton clothing could be the adequate protection that you need. I always tend to err on the higher side and say I want a little more protection than maybe is needed. But there are specially treated garments made from whether it's treated cotton or it's Nomex or it's a Kevlar based out there that are designed for these, because in some of these severe industrial environments, you're talking about some extremely high voltage possibilities where arc flashes are going to exceed these temperatures that we mentioned earlier of 35,000 degrees Fahrenheit.
Just in a more general idea, what are really the best ways to prevent an arc flash?
Yeah, so along with the lockout tagouts, the de-energize, and the things that Robert had just mentioned, your arc flashes can be caused by equipment failure or loose connections. So you want to make sure that your machinery is being well maintained. Again, human error is a huge cause of this, so regular analysis of your equipment, work practices, safety training, these are the things that you want to look at before you kind of look into the PPE, because PPE is your last resort in this type of a situation. And then we have a question, is arc flash the same as a lightning strike? In theory it is, because it's your electricity. That's kind of one of the things we compare it to most often, is a lightning strike, because it is energy going between two conductors. So in a very general sense, you could say that an arc flash is the same as a lightning strike.
We've also had a question here about the construction of the gloves themselves, so what kind of fabrics they're being made out of, whether they're a Kevlar, just what are the fabrics that are sort of used in an arc flash glove?
Most all your arc flash gloves today are being made of one primary has to be a flame retardant based material. If we try and dumb this down, which was the whole purpose of this webinar today, is think of it this way, is you want to wear a glove, in our case is what we're talking about, or this will hold true for your clothing that someone mentioned earlier, is that the clothing or glove itself, piece of PPE, will not cause any more damage to the person wearing it, i.e. it's not going to continue to burn, it's not going to melt on them. This is why we use a high temp neoprene coating and don't use nitrile or polyurethane or the foam nitriles or PVCs that are out there, because they have a much lower melt point, and these would just continue to melt onto you and increase your injury rate. So keeping anything, Kevlar, any good aramid, Kevlar certainly is out there, is one of the better ones known. Nomex is another good fiber. You mentioned the other PPE a while ago. There's a company, I believe it's called Westex, that makes a lot of flame retardant base materials that are later by other companies converted into clothing and hoods and things. So it needs to be primarily a flame retardant material, and make sure that there's nothing left on it that would maybe render that flame retardancy less effective, i.e. greases, possible cleaning fluids, things like that.
All right. So, Robert, we just had a question asking if you could maybe cover the gloves that are a superior glove produces for arc flash protection, just to give them, go over them again. And before you answer that, I'll just say too that we will be sending out a follow-up email to everyone who registered with the on-demand webinar and everything we mentioned today. So we will include those gloves listed for us. But Robert, if you could just list them off again. Okay.
The center one, the one we started and showed in this program, is our S18 KGNE, and that's your 18 gauge Kevlar base with the high temp neoprene palm dip on it. The next version up from that is again, it is a Kevlar based blended glove that gives you a higher cut resistant rating, but it also has the high temp neoprene palm dip on it and carries an arc flash rating of 2. The cal rating is 9.2 on that one versus the S18 at 8.2. From there we get into our Endura line of gloves, and there are 2 versions of those. The first one being the straight Endura glove, which is your basic high-end goat driver style glove with a Kevlar sewn-in liner inside of it. Gives you an ANSI cut level 4 rating, the A4 under the new standard, as well as an arc flash rating of 3, which now gets up to a maximum of having to exceed the 25 cals. And then we also have the Endura version with our oil block treatment. This is a brown colored goat skin. As I mentioned earlier, one big advantage is it keeps greases and cutting fluids, water, things like this from penetrating through the glove or being absorbed as quickly. Eventually, they'll go through. But with that, it'll help keep your hands dry. It gives you a higher arc flash rating, a level 4 of exceeding 40 cals, while still handling and carrying the ANSI A4 cut rating.
Great, and we're getting closer towards the end, but one other question here that was really just looking for some clarification is about what the risks are if you're locking out all forms of energy. Is there still going to be risk of arc flash? What risks are there if you are following the proper lockout technique?
Again, and I'll ask Matt maybe if he wants to chime in on this as well, but it's my understanding that there's machinery and equipment out there that can carry or have within it capacitors, devices that are designed to store energy. So even though you may have locked out the energy source to feed the machine, the internal components of the machine could still be storing energy in it and thus create an arc flash for you. So knowing your equipment and making sure that the entire machine has been de-energized, as well as the source of electricity or energy going to it has been cut off, that's going to be your most foolproof way.
Absolutely. I would definitely agree with that one.
Great. So I think we've reached the end of the question period for today. Again, I'd like to reiterate that we didn't want to get too technical with this webinar. And if you are looking for more information, there are those resources available. There were several jurisdictions represented in our attendees today. So I will point out as well that depending what country you're in, you may have different regulations. So please be aware of that and look into that if you have concerns. We will be sending out the email, as I mentioned before, so keep an eye out for that, and we will try to look for the answers that we weren't able to answer for you today and help you find the answers for that. If you do have any more questions, feel free to reach out to us either by email or calling in. And thank you for joining us today.
Yeah, thanks for having us.
Thank you all very much.